Hi guys, this is A2 Chemistry, transition elements, and we're looking at d orbitals. Question 1. On the following diagram, draw a clearly labeled sketch to describe the shape and symmetry of a typical d orbital. So, a typical d orbital would have four lobes present, and if we draw an orbital, let's call it dxy, so we would label the x and the y axis, and since dxy represents a d orbital with its lobes present between the x and y axis, so this is one lobe, this is the other lobe. Then we would continue with a third and a fourth lobe between the x and the y axis. So we would end up with a dxy orbital drawn this way. Question 2. For an octahedral complex, on the axis below, sketch the shape of one d orbital from the lower energy level and one d orbital from the higher energy level. So, in an octahedral complex, the approach of ligands is along the axis. So, the orbitals present along the axis would be at the higher energy level. So, that would be the dx square y square and the dz square orbital. So, I am making the dz square orbital here, which would be one bilobe on the z-axis and the other bilobe changing its shape into a donut ring and going around the z-axis. So this is the dz square orbital, and orbitals that are in the lower energy level are the ones present between the axes. So out of the three orbitals dxy, dyz, dxz, I'm making the xy, which would mean that the axis would be labeled as x and y, and the orbitals would be present between these axes. So between x and y, I would place one of the lobes, bilobes rather, like this, and the other bilobe would be present here. So this is the dxy orbital. Question 3. Transition elements have characteristic properties due to their partially filled d orbitals. Which two elements in the first row of the d block have only one electron in the 4s orbital of their neutral atom? So it would be chromium having an electronic configuration of 3d5 4s1, and it would be copper having the electronic configuration of 3d10 4s1. The d orbitals in an isolated transition metal atom or ion are described as being degenerate. What is meant by the term degenerate? All of the five 3D orbitals are of equal energy. Sketches of the shapes of the atomic orbitals from the d subshell are shown. In an octahedral complex, the d orbitals are split into two groups at different energy levels. On the diagram below, write an H in the box under each of the orbitals at the higher energy level. So, in the octahedral complex, the ones in the higher energy level would be the ones present along the axis, which would be dx square y square and the dz square orbitals. So, in order to figure out which is uh, the higher energy level orbital, we need to understand the names of each of these orbitals. So by looking at the shape, the first one has its lobes pointing between x and y. So this is the dxy orbital. The second one has a unique shape, so it has to be the dz square orbital. The third one has all the four lobes along the x and y axis. So this is the x square y square orbital. The fourth one has its lobes between the x and the z axis, so this is the dxz orbital. And the fifth one has all its lobes pointing between the y and z orbital, so this is the dyz orbital. So we needed to find out which are the dx square y square and dz square orbitals, which are orbitals 2 and 3 in the list given. which will be labeled with an H as stated in the question. So these are the two of the d orbitals at the higher energy level.